Gyroscopes are essentially circular things. A scientific gyro is usually mounted in gimbal rings, so that there is the wheel, here is the inner ring, here is the outer ring. All three sets of pivots, the axes pass through the center of mass of the gyro. Now I will tell you what precession is. A torque, by the way, is a twisting force. Instead of push, which is a force, you push a thing which is pivoted and it twists. So torque is a twisting force. The result of the twisting force is a movement, a rotation, but not in the axis in which you applied the torque. And we call that precession. So I put a torque on the outer ring, it is the inner that precesses. I put a torque on the inner ring, it is the outer that precesses. It will work in either direction. Oh, you're cheating, I can hear my critics saying. You're pulling it round as well as doing that. All right, we will satisfy the critics. We will hang a weight from the inner ring so that gravity and not I shall put on the torque. And there you see a precession. Not the sort of movement you really expected, because you are accustomed in higher mathematics to a torque producing an acceleration. Here, a torque produces purely a rotation. And if I put 3 times the mass on, I get 3 times the angular velocity. A different sort of device from our common experience. Now, what I want you to notice this time is, I'll spin it up again because it's getting a little slow. I want you to notice how it accelerates when I put the weight on and how it decelerates, especially how it decelerates. Having been convinced that a torque produces a velocity and not an acceleration, it must have an acceleration or it couldn't increase its velocity at all. And it must have a deceleration when it stops. So let us see if you can determine the rate of deceleration from that sort of angular velocity. When it comes round, I'm going to catch the weight and watch it stop. Hop. Ready again? Hop. There is an acceleration, but it is of a simply enormous value. Let us try increasing the torque by increasing the radius at which things happen. I put this long arm on, and of course it will precess anyway now because of the out of balance mass there, but I can now hang a weight on there and the precession rate increases because the radius is increased. And if I hang it on further along, I get a still bigger precession rate. If I hang it right at the end, you'll see it do something else besides merely go round at constant speed. I think I need a fresh spin. Hang on. Incidentally, this shaft has a peg in it. When you buy a toy gyroscope, it has a hole in it. The first thing to do when you bought a toy gyro is to fill the hole in with a peg that sticks out, because you break the string in the hole, and you never do from a peg. Right, we'll reinsert the torque arm. Come on. Yep. When it comes round, I'm going to hang this weight on, and I'm going to let it drop rather fiercely. You see it going up and down as it goes around? That process is called nutation. It is the result of an acceleration as well as a pure precession. Now, the two worlds. The fact that I can press on that and produce a precession of that, either way, has got nothing to do with the fact that I can press on that and produce a precession that way. Because I can hang a weight on this side, and at the same time, I can then attempt to make it go faster than it was going before by pushing on there, just like our volunteer was. And you see, the weight comes up or down. Now we've got something new, because a weight rising means an increase in potential energy. Where did the energy come from? The answer was it came from my finger, because now my finger was moving as it pushed. When I pushed on it and it was stationary, it didn't yield at all, so there was no power input. And even though there's movement of the inner ring, there is no power output, because that moves without being capable of producing any torque. If I resist that motion, then of course it immediately gives way to me. So these are the two worlds, separated for you, as they never are in electromagnetism. We have again been able to make the invisible visible, to dare to make the intangible tangible. Now,